In this, we are going to learn how to solve an inequality with absolute value sign. So, so when you have absolute value sign, so there are three cases, one with equality and two with inequality. So what is the first case? So let's say you have an equation with the absolute value sign. For example, absolute value of x equal a. So we assume that a is a positive number um, or 0. So, so this means that the absolute value means you disregard the negative sign, you disregard the sign. So that means it simply give you the value of the of x without the sign. So geometrically, you can look at this one as the distance from 0. So absolute x means the distance from 0 to the x. So if it equals to a, that means if the distance from 0 to x equal a means x has to be either x equal a or x equal negative a. So when x equal a, the distance is a. When x equal negative a, that's also the distance equals a. So that means if you have absolute x equal a, your values should be x equal a or x equal negative a. So the next one, absolute value of x less than or equal to a. So that means the distance from the origin to the x has to be smaller than or equal to a. How can that happen? So that happens if you pick a value which is in between negative and a, and you can see that the distance from the origin is less than a, less than or equal to a. So as a third case, what we have is, what about the case where absolute value of x is greater than or equal to a? If the absolute value of x is greater than or equal to a, that means the distance is larger. The distance from the origin to x is larger than a. So the only thing, only way that can happen is it has to be outside of the interval negative a to a. So that means it has to be the smaller than negative a or larger than a. So if you look at this in a number line, so let's look at all three cases in a number line. So that means the first one, so we have the number line, and then so let's say this is a, so this is the origin, so this is a, and this is negative a. So what the first one says, so the distance um, from the origin is exactly equal to a. So that can only happen at a or at negative a. So those are the two values. And if you look at the second case, and you can see what happened here. So you can see again we have a and negative a. So this is negative a and the origin and a. So what it says that the distance from x to the origin is smaller than. So that means it has to be in between a and negative a. Because if you pick any value here, you can see the distance is smaller than a, and also since there's an equal sign, you can include the corner points. That means anything in between this has the absolute value or the distance from the origin either less than a or equal to a. So as the last case, we have here the same two values. So we have negative a and a, and you can see that. So what this says that the absolute value, the distance from the origin, has to be bigger than a. So that means only way that can happen is either this side, which has more than, distance is more than a, or that side. So you can see now the distance from the origin is more than a. But also since there's equal sign, we can include the endpoints also. So that's the graphical interpretation of the solutions of this inequality. So let's look at a problem now. So as a problem, let's look at this problem. So solve the inequality absolute value of 5 minus 2x minus 1 greater than or equal to 4. So if you get a problem like that, our goal is to isolate the absolute value term, because if you isolate the absolute value term, then you can see that it's going to be one of those three cases. Since this is an inequality, it's going to be the one of the last two cases. So the answer, So we can start with the inequality. So let's say we have some x that satisfies this inequality. So that means let's say for some x, let's say for some x, we have 5 minus 3x minus 1 greater than or equal 4. So the so what we're gonna isolate. So that means we can add 1 to both sides, and then we can write this one as 5 minus 2x greater than or equal, by adding 1 you can see it is 5. So now you can see that this is the third case that we discussed earlier. So that means we can write the two solutions. Only thing happen is it's not x anymore, you have this expression. So what we can do in the definition, we're going to replace that x by 5 minus 2x now. So that means your two solutions now going to be 5 minus 2x less than or equal the negative 5, or and then 5 minus 2x greater than or equal 5. So that's what the theory says. It says that if it's absolutely greater, that means it has to be either smaller than the negative and larger than the positive. So now we're going to solve them separately. To solve this, what we can do is we're going to subtract 5 from both sides. That means it's going to be negative 2x. If you subtract 5, you're going to get negative 10. And then what we're going to do, we're going to divide. So that is the situation where we have to be careful. When you divide by a negative number, it's going to flip the sign. So that means if you divide by negative 2 both sides, so negative 2x, negative 2 is going to flip the sign, and then negative 2 over negative 10 over negative 2. Now we can simplify. You can see that negative 2 get cancelled here. So you get x here, which is greater than or equal, and you can see negative 10 over negative 2 means 5. So that is the first solution. Now for the second solution, we do the same thing. We're going to subtract 5 from both sides. So when you subtract 5 from both sides, you get negative 2x greater than or equal. If you subtract 5, it becomes 0. Now again, as before, we're going to divide by negative 2 both sides. When you divide, what happens? You're going to again flip the sign, and then 0 over negative 2 means 0. And then you're going to get, as before, they're going to cancel out. So you're going to get x, which is less than or equal 0. So those are the two solutions that we have. Now what we can do is we can write them as using the interval notation. So you can see the interval notation should be now, so it says x greater than 5 or x less than negative. So we can start with the solution. So the solution is, we can say, which is negative infinity all the way up to 0. Now the question is whether 0 is included, and you can see that when you put 0, it's actually satisfied because of the equal signs. That means 0 is included. And the union, the same thing, when you include 5, and you can see that you're going to get negative 5 absolute value, which is 5, and then you can see it's equal 5. That means 5 is also included. But we algebraically we get that, but we just checked. So that is the solution. And also we can draw the number line to show the graphical version of this one. So what it says, so we have these two numbers. So one is 0, the other one is 5. So what it says, that is less than 0, so that means this side, and the other one is says greater than 5, that side, so which is 0 and 5. So that is the graphical version of this. And also sometimes we also do the graphical version like this. We draw it like that, and then we're going to use the bracket version. So we can write it like that, and again the two numbers are 0 and 5. So we're going to mark this side, that's less than, and this is the larger than. So those are the graphical version of this. So that's how we solve the problem.